Good morning. Uh, I have this very interesting topic for machine shop basic course for all students. Uh, First, I will discuss about gears, especially the basic spur gear, and helical gear. Okay, and its formula and basic trigonometric function uses. Okay, first it is said that uh, pi is the ratio of the circumference over its diameter. Okay, we have this one, this spar gear, which is the teeth, and this one, this line is called pitch circle, and the distance between pitch circle to the other side is called diameter. In relation with this formula, the diameter is this one, and the circumference is this one, pitch circle. Okay? And number two equation of spar gear or gears is that module is equal to the ratio of diameter again. This time this is diameter, spar gear also, over its the number of teeth. This one, the number of teeth. Okay? So if we cut this off and make it straight line, this one we let this circle and we stretch it out into a straight line. Okay, rather, and this the now this is the linear. Now this is a linear or pitch circle, or in this one it's called linear pitch, but it's actually it's a pitch circle, the same with this one. Okay, this is the teeth. Okay, so we did not draw the whole number of teeth. We cut it this one. Okay, this one is the circumference. This one, we know that circumference is equal to pi times diameter. Okay, now we use this module. How to use this module in the gear? So we know that the pi is equal to the ratio of circumference and its diameter. So we have to replace it. Then diameter is equal to circumference over pi. So we have to replace it by circumference over pi. So module now becomes circumference over pi over the number of feet. So we transpose it to the other side, you know that. So we have module times the number of feet equal to circumference over pi. So circumference also is equal to pi times module times the number of teeth. Okay? So this is also circumference. So this is also pi times module times the number of teeth. Okay? So therefore, the distance between two teeth is equal to, if we divide this by the number of teeth, so we have this one. If we divide this by the number of teeth, we have to cancel out this one, so this becomes pi times module. So therefore, the distance between teeth is equal also to pi times module. Okay? So this one is pi times module. Pi times module. Pi times module pi. So therefore, pi times module times the number of teeth is equal to this one. This pi times d, which is equal to circumference. So we cancel out pi. So pitch diameter become module times the number of teeth. Okay? So therefore, the pitch circle diameter is equal to module times teeth. Okay? Module times teeth.
Ang yabang ni Danjo. Ay, sorry.
So where are we? This the third. We review. Okay. This is the pitch circle diameter. This distance is pitch circle with this module times the number of teeth. Okay. So how about its outside diameter? So outside diameter is, we have this one. This is we call it the addendum. And this one also addendum. Okay. So outside diameter become, or we know that. Okay, we have to erase this one. The empirical formula, one of the empirical formulas, we have this one, that addendum is equal to the 1 times 1 is coefficient of module. Okay, or simply addendum is equal to module. So outside diameter of the tooth, outside diameter of the gear, simply module times teeth, which is this one, the pitch circle diameter, plus 2 module, because we have this one. This addendum is equivalent to addendum on the other side also. So module and module, this is 2 module. Okay? So shall we say that it is factor it out? Or like this one. So OD is equal to module times the number of teeth plus 2. It could be used also. Okay? How about its addendum? This one, addendum rather. The distance between the root diameter, this is the root diameter, and the pitch circle diameter equivalent to this one is called addendum. Okay? It's called addendum. This one the distance between this tooth, this is root diameter up to the other side, and this one is called didindom. Didindom. Okay, this is didindom. Okay, didindom is equal to, the empirical formula for didindom is equal to 1.25 times its module. Okay, and then we have to make a shop drawing or fabrication drawing of a spar gear. It looks like this, okay, in machine shop. This is the cross section, this is the center, this is the hole inside the meter of gear blank. Okay, we did not to draw it like this one round. You have to cross or cut it half. Okay, this is the uh, pitch circle diameter, which is this one, mg. This is one simply is its diameter. Its diameter, outside diameter, we call it big D. Okay, outside diameter, which is equal to this one. Okay, and that's all. We have to make a hatch, then given its inside diameter for shafting. And that's all. Okay, but of course in the drawing you have to put the data, gear cutting data, which is number one is the number of teeth, J, the module, the pressure angle, which is equal to the standard word widely used is 20 degrees. It can be found in every gear cutter, and you must indicate the addendum, which is equal to 1, the factor, or the coefficient, and the addendum you have to indicate also, which is the 1.25. Okay, and the hole depth, if you hole depth, this is called the hole depth. From this top land of gear up to the throat diameter is called hole depth. Hole depth is equal to, you have to add this one, but this is also, it is 2.25 times module. Okay, that is all for Sparker. Now the next topic I will be discuss is what we call this helical gear. Helical gear. Okay, we have to continue. Then now is this, I discuss about helical gear. Previously we discussed about the spar gear. Okay, this is the what we call this pitch circle diameter, as we know. This one is the addendum, and this one is the didindum. Okay, this is the outside diameter. Okay, and we know that this distance is equal to pi times module. In helical gear, that is also equal to pi times module, but in a different, but we did not, we do not need this one. We do not need this one, this distance. The other distance I will show you. Okay. This is the center line. Again, we have to look at it in top view. We have this one. Wow. This is the top view. And we cut it. This is the face width of the helical gear. We look at the top view. This is the line of tooth. Each tooth is one. Okay. So, okay. Okay. This is called helix angle. Okay. That is helix angle. You make it helix angle beta. Okay. It's the line of tooth. Okay. And we have to resolve this one. If we make an imaginary line perpendicular to this line, like this one, it's perpendicular to the helix angle, and the other one is this one, imaginary line. We notice that it is perpendicular. We notice that it is like an spur gear when we stretch out this one. Okay, so then this distance in spur gear is also is pi times module. Okay, this distance times pi times module, but we need a helical gear, so we need this one, this distance x, distance x. Okay, we don't need this one, we need this distance. Okay, so we have to make a bigger drawing, a detailed drawing. So we have this portion, this one, is that it? Okay, this one, this is the center line, this is the it. Okay, okay, this one. Okay, so this is the beta, helix angle beta, and this one is x. Okay, this is also this is 90 degrees. So 90 degrees minus beta, this is 90 degrees minus beta. Okay? So this is also 90 degrees minus beta. Okay? And this one also is, if this is 90, and this is 90, so this is equal to 90 degrees minus 90 degrees minus beta. Okay? So that become 90 degrees and minus 1, 90 degrees, this is 0. So this out. Minus 1 and times minus beta is equal to positive beta. So this is also called, this is the beta. Okay, now we have a triangle, this one. We have a perfect right triangle, this one. Perfect right triangle, where this is equal to x, this is equal to pi times module. This is beta. Okay? So this become adjacent. This is the adjacent beta. This become the pi m over x is equal to cosine beta. Okay, so that the x will be pi times module over cosine beta. Okay, so we found this x. So this one x is equal to pi times module over cosine beta. Okay, if we multiply this, the number of teeth, what happened? Multiply it by number of teeth, what happened? It's also a circumference. Okay, it's a circumference as relative to this distance. Relative to this distance, it is also a circumference. So therefore pi times the number of teeth is also equal to circumference, which is circumference, or is this equal to pi times diameter. It's per circle diameter. Okay, you have the cancels out the pi. So to pitch circle diameter, based on this one, we have module times j over cosine beta. Okay, so the pitch circle diameter of helical gear is this one. Okay, d is equal to module times the number of teeth over the cosine beta, which is the helix angle. Okay, and simply the outside diameter the same, with the spur gear, like this one. The big D also become module times z, number of teeth, divide cosine beta, plus simply 2 module. Okay, that is the pitch circle diameter of helical gear. Okay, if we make a shaft drawing for helical gear, like this one, this is the center distance, and this is the inside diameter, and this is the root diameter. This is pitch circle diameter. Pitch circle diameter, which is outside diameter. Outside diameter big D, which is equal to module, that's the number of teeth, over cosine of helix beta. Cosine beta, like plus 2 module, 2 times module. Simply the pitch circle diameter, you have to indicate this one. This is equal to G over cosine beta. And the direction of tip, you must emphasize. If we make a line, diagonal line like this one, it's called helical gear. Now it can be recognized as helical gear. This is the helix beta, and this time this is the right hand. This one is the right hand direction. Right hand direction. Again, in helical gear, you have to also to indicate, or it's gear cutting data. Gear cutting data. You have the number of teeth, the module, and the pressure angle, which is worldwide use is called to 20 degrees. Now this time we have the helix angle. Okay, and the direction of it is our right hand or left hand. Addendum factor, addendum coefficient, which is 1. The addendum coefficient is equal to 1.25. And hold it again, we have 2.25 as empirical formula. This is called empirical formula. Empirical formula. Okay, that's all. How about the helix angle beta? Okay, now we discuss it. So, in helical gear, you must have a helix angle theta. Helix angle theta okay, yeah, this one. If this is the pitch circle and this pitch circle diameter of gear 1, gear D1 or sorry D1, and this one is pitch circle diameter D2. Okay, this is the center line. It's the distance. Okay, so this is the center to center distance. This is the gear 1 and this gear 2, or pitch circle D1 and pitch circle diameter D2, pitch circle diameter 1. So therefore circumference will be D1 plus D2 over 2. Okay? Or you can write this as D1 over 2 plus D2 over 2. So what is D1 in helical gear? D1 is helical gear. The center distance will have D1 is of helical gear is module times Z over cosine beta over 2 plus we must put it as 1. We're preparing as this 1. Okay, and this time mg for 2 module times the number of teeth over cosine beta over 2. Okay, so we have the same denominator. So we can write this as mg1 plus module Z2 over cosine beta over 2. Okay? Okay? Or transpose this one, we get 2 of center distance times cosine beta. Okay? So we have this one. C, this is, or we can write this one as cosine beta times 1/2. Okay? So we can write this one mg1. We factor out f, we have m times z1 plus z2 over cosine beta times 1/2. Or we can make directly 2 cosine beta, so that center will become 2 cosine beta times c module z1 plus z2. So therefore cosine beta will be cosine beta will become module z1 plus z2, divide this one, 2 cosine. Okay? Okay? Or we can make it this one, we have to multiply it by, by both equation, we have to multiply it by 1 over 2c. Okay? And this 1 over 2c, which will cancels out. This become cosine beta over mz1 plus z sub 2 over 2 times c. Okay? Now we know that the cosine beta is equal to module times the z1 plus z2 over it's 2 times the center distance. So therefore cosine helix beta will be equal to arc cosine of m z1 plus z2 over 2 times its center distance. Okay? This one. That is helix beta. Helix beta. Okay? Okay, that's all for today. And next I'll be discussing bevel gear. Bevel gear. Or mitre gear. When we see mitre, it is composed of two mitre gear is 45 by 45 degrees. Okay, that's all for today. Next is bevel gear.